Hi there, my name is Victor. In this video, I'd like to compare monorepo tools such as Lerna, Yarn Workspace, or PNPM with a different tool called annex. Okay, so I'm going to show how to add annex to an existing workspace, to an existing monorepo, and what kind of benefits you will get by doing so. To do that, I'm going to use this example workspace, which has two packages, the header and the app. The header is a library of React components. It's a very small library, but it will work okay. And it has two scripts. One script to test the header using jest, and the build script to build the header library using rollup. Next, the application. The application we have here is a React application, and it was created using create React app. The application uses the header, and it has three scripts. There is a test script to run the tests for the application, the build script to build the app using the Webpack, and also we can serve it as well. To show you that the repo works, let's run two commands. Learn run test is going to run the JS test for both the projects, and learn run build will run the rollup and the Webpack builds for the library and the app. One thing worth noting is how we specify the dependency of the application on the header package. Right? We do it like this. And if you know Lerna or you saw examples of using Lerna online, you know that sometimes folks do something like this. They put a star instead of the path, right? And this does work. So what this does is it tells Lerna to still link the header package inside the application's node module. So when we build the application, we can see it, right? However, that only works for very basic scenarios, right? Where the header doesn't have to be processed, right? In our case, the header has to be compiled, right? So this already is a problem, right? Basically, in practice, for any serious repo, this is not an option, right? So this is an option, right? So often folks compile packages into some folder, and then the application would depend on the compiled artifact, right? The problem with this is that if we actually interact with the source code, the editor, VS Code or WebStorm, won't be able to help us out in here, right? VS Code doesn't know that the header we're seeing over here actually points to the header we authoring in the same repo, right? So the go-to definition won't work correctly. The refactoring won't work, right? So it's just a very poor editor experience. So basically, we have a choice, right? We either have the editor experience done right, and then the build stuff is just completely screwed up, or vice versa. We have the build stuff working correctly, but then the editor experience is messed up, right? And that's one of those things that you need to be mindful of when you set up your monorepo, when you build multiple projects in the same place, that most of the time you don't see covered, right? It's important to pay attention to such details. To add annex to this repository, let's run npx add annex to monorepo. What this command is going to do, it's going to analyze the source code of this workspace, figure out what projects we have, right? And it's going to add the minimum amount of configuration required to enhance this repo with annex, right? So it's done. As you can see, it was fairly quick. It gives us a few pointers on what to do with this workspace, and we're going to explore them in a second. One thing I want to draw your attention to is that I've chosen to enable Annex Cloud, which is a service you can enable for any Annex workspace, and it gives you a lot of cool stuff. I'm going to sort of point out what part of what I'm showing is enabled by Cloud and what part is just enabled by Annex. Okay. So let's look at the files that have been added. Okay, there are two files that have been added by the script. The workspace.json file contains the project, lists the project that the workspace has. In this case, the script deduced we have two projects, the app and the header. Right? And annex.json is a file that basically configures Annex. Tells Annex how to run commands, where things are located, describes certain variants. Okay, let's verify that Annex works. To do that, let's run the simplest of commands, annex step graph. As you can see, Annex was able to figure out that the app project depends on header. For such a small project, it's not very impressive, right? Because it's sort of obvious. But for a larger workspace with, say, hundreds or thousands of nodes, this can be very handy. Let's run similar commands to what we did with Lerna. So let's start with testing. Okay, that worked. Next, let's build the app. As you can see, it's not just building the app itself, but also the package the app depends on. And in this case, this is the header package. Because I'm connected to cloud, I can click on this link and I will get to our next cloud where I will see the details about the last command that has just happened, right? In this case, I can see that there are two tasks that are next executed. The first one is building the header, and the second one is building the application itself. If I do it again, the command will run instantly. So how did it happen, right? So Next was able to figure out that this computation had already happened, right? We don't have to rebuild it. Even more so, it was able to figure out that the dist folder actually matches the computed value from the previous computation. So it basically did nothing. It skipped the whole thing. It just printed the cache terminal output, right? And if we click on the link, we will see that both the tasks right now are cache hits. All right, so how does Next know that before it builds the app, it needs to build the header package first? To see how it knows, let's open Next the JSON. And in this file, we have these rules, these invariants defined. This rule, for example, said that before we build anything, before we run the build target, we must run this target for all the dependencies of this project, right? So in this case, the header is a dependency of the app. So before I build the app, it needs to build the header, right? And there are many other ways you can express sort of relationships between targets in an X. This is just the simplest one, right? And this is the a general rule that applies to all projects. You can also do it on a project by project basis, right? But the idea is that you can sort of describe, you can tell an X how projects, how tasks relate, so it knows, what to execute. And the cool part in here is that if some of the projects, some of the dependencies changed, right, an X is going to rebuild them. But if another dependency, for example, hasn't changed, and an X had it in its cache, an X is going to restore it from cache, or even just leave the files in the dist folder if the files are already correct, right? So this combination of invariance and computation cache, right, this mix, is actually very, very powerful and allows you to express very interesting scenarios. Let's change app.tsx and run the same build command again. And as you can see, this time, the header package, the task of building the header was retrieved from cache, and the app was rebuilt. So only one of the tasks was cached. And this, of course, works for non-build targets as well. If I run the test target twice, the test command twice, you will see that the second time the result of the command was retrieved from cache. Let me show you another very cool feature of Next, and it's called affected or code change analysis. To do that, I need to check my changes and create a new branch. So what Next can do, it can look at your branch, see what you change in your branch and the nature of changes, and it can then run the test or length or build for the minimum number of projects in your workspace to verify that your branch, your PR, is safe to merge. In this case, it's an empty branch. We haven't done anything, so there is nothing to test, nothing to run. If I, however, go and change the header package, for example, Next will be able to see that, right? And it will know that the header package can break the app, right? So if we run the test again, Next is going to test both the header and the app. And if instead I only change the app and run the same command again, Next will know that it doesn't have to retest the header. Right? It could not be broken, but the app can be, so it's going to retest the app. To use the Next plugins, I need to make sure I have them installed, and I already did that in here. So now we can go to workspace JSON and define targets for our projects. So by default, Next will use UNPM scripts as targets. So when you do an Next build, when you execute an Next build header, it's going to search for the build npm script for the header package, right? But you can define your own targets. You don't have to use npm scripts, right? Because Next is not built for JavaScript only. Right? It's a general purpose tool. To save some time, I'm going to copy and paste the target configuration, right? There are two things I want to point out. One is that the options map in here is passed into the package function from the narrow web npm package, right? And the second thing I want to point out is that the auto-completion for the options map works. The VS Code integration provided by Next make sure you get a rich dev experience, right? And things like auto-completion are based on the metadata provided by each plugin, so they are plugin specific, right? The comparison I often use is that an executors are more like TypeScript and NPM scripts are more like JavaScript, right? Executors give you a lot of structured way of interacting with them, right? You get parameter normalization, so good defaults, editor support, and lots of other cool things, right? But they do require a bit more typing. Next, let's remove npm scripts for this package and all the configuration files we no longer need. Same steps for the application. Let's add the required targets. And the way I usually go about figuring out how to configure my targets is I create a new Linux workspace with a similar app, and I use the configuration for that workspace as a starting point. And once again, because I use a plugin that has already the whole Webpack story implemented, I can remove all the configuration files from my application. All right, let's make sure that everything works. Let's start by running the tests for both the projects. Next, let's build the app. And before building the app, I'm actually going to build the header package because it's a dependency of the app. Okay, so the build succeeds. I'd like to point out one thing that I drew your attention to at the beginning of this video. When I'm building the app, I'm actually going to use the build version of header. Right? So that's why it has to build the header package first. But when I'm authoring the app, when I'm navigating around, when I'm refactoring, when I'm going to this token's definition, I'm going to source, right? So I get the best of both worlds. My authoring experience is very nice. My VS Code or WebStorm setups will work perfectly. And my build is fast and incremental. Alright, so if you want to add an X to a Lerna repo or Yarn Workspaces repo or PNPM repo, it's very easy. Simply run add an X to monorepo. And it will do basically all the work for you, right? You're going to get an X core in your repo in a few minutes, and you'll get computation caching. An X will smartly rebuild only what's effective. You get distributed builds. You get GitHub integration, which can be very handy for larger repos, VS Code and WebStorm support. Just a lot of really cool stuff. And the focus of this part is sort of more on performance, right? What's important as well is that nothing has changed in regards to functionality in your repo. Right? You're still invoking the same NPM scripts that are doing the exact same things we were doing before. If you're using, say, Yarn or PNPM, you're still using them, right? Nothing has changed about your repo functionality-wise. Everything just gets a lot faster. Now, if you go further and you invest in the next plugins, you get other benefits. You'll get a much better developer experience, especially when it comes to mixing a bunch of really cool tools, like, say, Next.js, Storybook, Cypress, Tailwind, all of them working together without you having to do anything. Things like that. It's much easier to create a consistent dev experience for your team, for example, right? This is more of an organizational type of scaling. All right, thank you for your time. And if it looks interesting, check out an Exodev to learn more.